Welcome to Chapter 9. Chapter 9 has to do with something called hypothesis testing. So it's building on the material that we've taken, especially in the last two chapters, and we're going to specifically focus on when we have one sample. We're going to make a statement, and then we're going to test whether it is true. So we're going to talk about the principles of hypothesis testing, how to use it for mean or proportion, and it does have some carryover from confidence intervals. And we're going to evaluate the assumptions of the hypothesis. So in this particular case, you make a claim that the mean monthly cell phone bill in the city is $42. We wish, right? But as we know in Canada, they tend to be quite a bit higher. Well, there's also another example where that the proportion of adults in the city with cell phones is 0.88 or 88%. So those are a couple of statements. Now, somebody might say, well, you're right. Somebody might say you're wrong. You would have to prove that. And there's various ways to do it. You could actually do confidence intervals on this, but you can also do hypothesis testing. So we need to test whether the mean in this particular case is 30. Or we test to see that it's not 30. So in this particular case, one of the things that is important, you're going to have two hypotheses or hypotheses. You're going to have the null hypothesis. The null hypothesis always has the equality sign in it, equal to, less than or equal to, or greater than or equal to. And the alternate hypothesis will have the not equal to, less than, or more than. And this is called the null hypothesis, identified by HO. And so we're going to make a statement. Is the diameter of the bolt 30 millimeters, or it's not? So we're going to, in this particular case, we go through the process of testing. Is the population mean age 50? The opposite of it being 50 is it's not equal to 50. We don't care whether it's higher or lower. So this is a two-tailed test, which is very, very similar to confidence intervals. We take a sample, and the sample mean age was 20. This is significantly lower than 50. Now, you can't just automatically say, well, the population average is not 50. It depends, of course, on standard deviation. But looking at the numbers, it's likely that it's not true, or that the mean is not 50. So you have the area underneath the curve. You look at the 20 and say it's unlikely, but I'm not going to stand in front of a class or a board of directors and say that I am confident that it is not 50. I'm going to test it using a hypothesis test. Again, I could use a confidence interval to determine the low, in this case, the lower limit. And if the 20 is below the lower limit, I would be pretty confident that it's not, but I'm going to use a hypothesis test. So is it far enough away? Point number 3, how far is far enough away to reject the null hypothesis? In other words, state that it is not 50. So you have the tails, which are the rejection region, which are the probability that the null hypothesis is not correct, or you would reject. So areas or regions of rejection. The large area underneath the curve is always going to be your fail to reject, or region of non-rejection, as I have in this slide. You have a couple of potential errors that you need to be aware of. Reject the true null hypothesis. As it says, this is a false alarm. So in other words, you reject it, but it was actually correct. And so it's a lot of it's again dependent on the level of significance, the alpha. Type 2 error and is you fail to reject the null hypothesis and you should. So it's a missed opportunity. So what the heck does this all mean? Type 1 error, you have a candidate that you're interviewing for a job. And you tell the person that you're interviewing, sorry, you did not get the job. But that person would have made an awesome employee. So in this particular case, you tell the person, sorry, you don't have the job. But if you had hired them, that person would have been a very good employee for your company. So that's a type 1 error. You reject something you shouldn't, or turn down something you shouldn't. A type 2 error is you hire an employee and they're a dud. They're not very good. So you hire somebody you shouldn't. So the more restrictive you are, so the smaller the tails, the less likely you are. So if you reject most of the candidates, for example, so if you reject most of the candidates, there's some candidates that you reject that you shouldn't. But if you don't reject enough candidates, then you're going to hire some people that you should not. Now, for example, Amazon. I have a student who works for Amazon. I actually have 4 of them at this point. And they told me that when they are interviewed, Amazon looks for, they don't look for the bottom 50. They don't look for Q1 and Q2. They will only hire people if they feel they're above average. So they want the top half of the workforce. And that's what they get. They pay very well for their manager positions, and they pay for the best, and they want to hire the best. There is another company called Schlumberger. They're an engineering company. What they have is they expect you to, from whatever level you are in the organization, to rise at least 2 more levels. If they do not feel that you are capable of rising 2 more levels, they will find some way to get rid of you. So in other words, they want people who are really good. It's a way of doing that. So if this is a interview at Amazon, they're not going to take anybody who is below average. They're only going to take average and above, where really they only take above average. So this is just a table that says the same thing as the previous slide. The confidence level is 1 minus alpha. The confidence coefficient is the probability of not rejecting HO. And the confidence level hypothesis is, as you can see, it's basically the larger number, the 90, the 95, the 99 that we've been talking about. So don't spend a huge amount of time worrying about type 1 and type 2 errors. Just intuitively know, and you would know, that if you type 1 error can only occur if HO is true, type 2 can only occur if HO is false. The larger the level of significance, the greater the probability of type 1 error. So this is just information for you to try and make it a little bit more clear. And I wouldn't spend a huge amount of time on it, to tell you the truth, but I just want to identify that you can make an error, and you people know this. You can accept something that is you shouldn't have. I would anticipate we've all done that. Okay, we've said yes to something, we wish later, oh, I regret that decision. Or we turned down something and we wish and we shouldn't have. So those are just type 1 and type 2 errors. So with the two-tailed test, it looks a lot like a confidence interval. And there's rejection regions above or below. So you have equal to and then not equal to. That's a two-tailed test. And you need to divide the level of significance by 2, so half is on the left and half is on the right. And again, hypothesis test, we will focus on the bottom right-hand one, where the population standard deviation is not known. But we'll briefly just talk about where it is known. So you calculate what's called the test statistic, the Z-score. Is one way, but the way that we're going to do it is the modern way. It was like an 8 or 9 step process to go through hypothesis testing when I took it at university. But now the focus is we can basically make this a 3 or 4 step process and focus on p-values. When instructors who teach statistics sit around, we don't say what was the Z-score and where was the critical value and all of this jargon and terminology. We just want to know one thing. What's the p-value? So that's what I'm going to teach you. That's the way it's done. All I need is the p-value. And sometimes I need the level of significance. So you're going to see this. That's what I'm going to focus in on. It simplifies things dramatically, but two things. It's the way it's done in industry, and it's way easier to understand. But again, with technology, we can calculate the p-values. We don't have to bother with all of that. This is a critical slide. Okay? Very important that you have this ready for you. If the p-value is less than the level of significance, you reject HO. So if the p-value is 0.03 and the level of significance is 0.05, you reject HO. If the p-value is greater than or equal to the level of significance, you fail to reject or do not reject HO. So if the p-value is 0.08 and the alpha or the level of significance is 0.05, you fail to reject. And the way to look at it, the lower or smaller the p-value, the greater the chances you're going to reject HO. So if you gave me a very low p-value, like 0.0027, I'm going to reject HO. Anything less than 1% or 0.01, you would always reject HO. So here are the steps. We're going to go through it, and we're going to go through the steps. And really, point number 3, we don't need to do. You don't need to bother with that. We just need to find the p-value. So this is now a 4-step process. For years, we used to teach an 8-step process, and now you can do it in literally half the number of steps. And of course, that means less opportunity for error. So you state the null and alternative hypothesis. The null hypothesis is a reminder will always have the equality sign. It's equal to, which will have the pairing of not equal to. It is less than or equal to for HO, which will have the pairing of greater than, or it has the greater than or equal to for the null hypothesis, and H1, which is the alternative hypothesis, will be less than. You determine the level of significance and the sample size. Now, you as a manager determine the level of significance. And like I said, what are the consequences, not so much of being right, but what are the consequences of being wrong? And I give you a very simplistic example. If you make a statement that light bulbs will last a certain length of time, they're going to last a certain number of hours, and they don't. In other words, they last longer or last shorter. Now, if they last less, then your customers will be dissatisfied. But if they last too long, you're not going to be selling any more light bulbs. All right? That's a two-tailed test. And the consequences of being wrong there are consequences, but not as severe as the consequences of the example I'm going to use next. What if you install pacemakers for people's hearts? All right. So in this particular case, you say the pacemaker will need to be replaced every 7 years, whatever the number is. What are the consequences if the pacemaker doesn't last 7 years? Probably fairly dire for the person who has the pacemaker. So if you state that the pacemaker needs to be replaced on average every 7 years, and something happens less than 7 years before it gets replaced, then there can be significant consequences. So the consequences of being wrong that it's not 7 years is significant. And in that case, that's a one-tail test. That would be left tail, that it's the pacemaker lasts too long, it's going to get replaced anyways. But if it doesn't last long enough, you're going to have severe consequences. So you, in this case, this is going to be the same process for T-scores. So you just calculate your Z-score. You determine your critical values. So your Z-score is -2 and +2. But what's really important is you find the p-values. The p-values are the shaded areas that are the tails. So you have 0.0228 on the left and the same number on the right. You add them together to get a p-value of 0.0456, or in other words, 4.56%. But the p-value is less than the rejection region, than alpha. So you reject HO. So in other words, the p-value is in the tail. There is sufficient evidence to conclude that the mean diameter of a manufactured bolt is not equal to 30. So that can affect the strength of the bolt, how long it will last, etc. And it may not fit properly. So all you need to do, we can even skip the Z-score calculations, and we'll focus in on calculating the p-values. In this particular case, we have the same kind of thing, and this is a confidence interval. And you can see that with the confidence interval, which we did in the previous chapter, that 30 is just a smidge, just a little bit above 29.9968. So it also, you can use confidence intervals that if the mean is below the lower limit or above the upper limit, you can reject. So you can use either methodology, but we will use both. The most common way is to do a hypothesis test, not to use confidence intervals, but you can use both. So do you ever know, again, we've seen this before, do you ever truly know standard deviation of population? Nah, not really. All right, so the same kind of steps, except you use T instead of Z. The T statistic looks a lot like the Z score, except for the denominator where standard deviation of the sample is used. So in this case, you can see that they're testing to see whether the average cost of a hotel room is $168. And travel and tourism use this all the time. I've been to Vegas, some of you probably have too. They give statistics about what does the average person spend. They would also have that broken down into how much is the average night for a hotel, how much do they spend on food, how much on gambling, how much on entertainment, things along this line. And you do a sample, and the sample says is 172.5. You have your standard deviation of $15.40, and you do a hypothesis test at 5%. So the alpha is 5%. All we really need to know is what's the p-value. You see your null and alternate hypothesis. You do the calculations with a focus on the p-values. Don't really worry about this other. On your assignments, I've tried to pick questions that have p-values. And we're not going to bother with all of this other stuff because it's redundant. We don't need to do that. It's a simpler way to do it. This is not necessary to know. Just put it in for illustration purposes. You can assume that the population is normal, or you need to do that. And you can look at box plots here to determine like confidence intervals. Over the box plots, of course, as you know from previous, will also tell you how skewed or not skewed. So you can look at things like mean and median if you've forgotten. They're fairly close together. You actually look for skewness. It's 1.0241, and it's only slightly skewed. And that's fine. Like it's just slightly asymmetric or off kilter, whatever, however you want to describe it. So, you should test for that. If you've got a sample that is very skewed, then you can't use normal distributions, and you would need to take stats number 2. So this is what we're going to pay attention to. This, I can give you a website for this, but I may just ask you to do this in Excel. Last term, I gave the students Excel because we didn't use this particular book. This book is one of the reasons, again, I picked it, was it has a lot of really good things like this. And you should have this ready for your tests. You've got the null hypothesis, level of significance, as you can see, all of the 5 things you need to enter. You've got the formulas already set up for you. You don't want to be entering these on the test. It even gives you the if statement that if the p-value is less than the level of significance, you would, right? So if the p-value is less, you reject, and if it's, and the other conclusion is do not reject. So I've even had some websites that will actually give the answer. If I'm a student, I am making sure I have this ready for my test, for your test, and I will test it. What I would do, just as a thought, I would take this, I would put it into my spreadsheet exactly the way that it is, make sure that I'm getting a valid result, and then I'm gold. Then I am sure that I've got the right answers. Now again, this is for a 2-tail test. All right. And you can see all the data, like the negative t inverse dot 2t, and you take the negative out, and you can see B5 and B12. You can make those absolute references if you want. It doesn't show perhaps particularly clearly on this what the row numbers is, which is a bit unfortunate, but yeah, just count down 12. All right. So I'm going to have this ready if I'm doing it as a student. And then as a student, I only have to put in the 5 values at the top, and I read the p-values. We're not going to go through that other convoluted, more difficult and out-of-date way of doing things. Just tell me the p-value. I've really gotten to the point where that's really all that matters, because we as stats instructors, that's what we talk about when we talk to each other. We don't calculate z-scores and stuff like that. All right, here's again a confidence interval. So in this particular case, we had 168 was our hypothesized mean. Well, 168 is between the lower limit of 166.14 and the upper limit of 178.86. So 168 fits in the non-reject region, or the fail to reject region. It's not in the tail. It's in between these two numbers. So we fail to reject. Now, a one-tail test. You can see the pairings that I mentioned before. And if you want, you actually look for which direction the alternate hypothesis test points. So the top one is a left tail test. The bottom one is a right tail test. So if it's a less than sign, it's left tail. If it's a greater than sign, it's right tail. So in this case, the rejection region will all be on one end, not on both sides. It'll all be to the left, entirely to the left, or entirely to the right. So you can see this is a left tail test. The entire rejection region is below. And in this case, a right tail test. The rejection region is to the right. The beauty of the p-values is you just need to know the p-value and compare it to the level of significance. So in this particular case, you have to be very careful when you read the statement. This is probably the most difficult part of hypothesis testing. The way that we're going to do it is not the calculation. The most difficult part of hypothesis testing is reading the statement. Now, in this particular case, when you read the statement, can either be stated as HO or H1. When you read the statement, it says the average cell phone bill is over 52. That would actually be H1, where the mean is greater than 52. It didn't say 52 or greater. It says more than 52. So in case this, because they're in dollars, we're starting at 52 and 1 cent. So you're going to be either given HO or H1. You are not always given HO, but in this case, the mean, and you can see they've got it highlighted, is greater than 52 or over 52. Oh, so that is H1, mean greater than 52. HO, the other pairing, is less than or equal to 52. So this is a right tail test, and we're given a level of significance of 10%. So in other words, if the p-value is less than 0.1, we're going to reject. If the p-value is larger than 0.1, we fail to reject. So we just need to find the p-value. We find the p-value, all right, and using Excel, and we find the p-value is 0.2937. That's way higher than 0.1. So do not reject, or as I normally refer to it as, fail to reject. FTR HO. So once again, I'm going to have this as a spreadsheet to do a hypothesis test. And this is for the p-value for the upper limit, for the right tail. Remember that it was above 52? So again, on my spreadsheet, I'm going to have it labeled. I'm going to have all of these done. I'm going to test it by making sure that I get the values just exactly as they are on the screen. I can actually copy the one that I did for two-tailed and modify it because they're very similar, as you may have noticed. So just start from scratch, but I'm going to vet it. I can even put in the if statement. And so not only are we trying to show you statistics and how to enter formulas and things along this line, like whether it be as simple as the line that says equals B6 minus 1. That's a very simple formula, but I've had students in statistics who don't even know how to enter a formula. And then so you see square root for square root, you got t inverse for the t value, and the absolute value, that's what ABS stands for in the second last row. Then you've got an if statement. So we're not only just teaching you how to use Excel to calculate values, and there's an add-in to the course that's called PH Stats. The problem with that is it's already done for you, which is fine, and we will potentially look at that, but that's proprietary to the textbook. We're trying to show you something that you can use anywhere. And by the way, if you happen to work for a company that uses the Google product, like Google Sheets, it's identical. It's exactly the same. It's the exact same statements. So you don't have to modify anything. Now, for proportion, as we might remember from the previous chapter, proportion has to do with Z-scores. So but the same type of thing. What we care about is the p-value. That's really all I want. Tell me the p-value and tell me the level of significance. I don't care how you got there. I know how to get there. That's to make my conclusion, I need those two things. Here's again all the formulas, all right? So in this particular case, claims that it receives 8% response from its marketing. So again, it's in percentage. Now, if it's 0.08, that's proportion, but 8%. So we want to test this claim. There's a random sample of 500 were surveyed with, and 25 responded. So what you need to do is 8 is what you say the population is, but you need to find out what the sample was. So we're going to do that. So in this particular case, again, this is a lot of stuff that I just included just to show you. And in this case, it's two tails, as you can see. But one of the things you're going to have to find out is what was the sample average? And you would take the 25 and divide it by 500, which would be 5%. But the important thing is the p-value. I've stressed several times already, tell me the p-value. So you see the p-value is 0.0136. 0.0136 is less than 0.05. Reject. The null hypothesis is not correct. That 8% is false. You can mathematically prove that it is wrong. And we didn't ask whether it was lower or above. We just said it. They said it's 8%. They're wrong. Simple as that. So here's again some information that you can look at that you have to pay attention to. Is the test one or two-tailed? And all of this other stuff like random sampling and things that we've talked about. Is it a large enough sample? Did you survey 3 people? Things along that line. So there's a lot more that goes into it than just, in the last example, they had 500. Now, is that enough? I don't know. We need to find out what the sample size would have to be. And we did that in a previous chapter. You need to find out if the results are statistically significant. So are you going to reject the null hypothesis? And and the sample size has a lot to do with the conclusions we can draw. You can see that it's more likely that when the sample size gets very large that we can reject the null hypothesis. When the sample size is very small, it's more likely we're going to have failed to reject. But sometimes you just don't have the time. Somebody says, I want results in 2 or 3 days. You don't have the time or the money to go out and survey like 500 people. So we talked about the principles hypothesis testing, two-tailed tests, left tail and right tailed. It is critical, absolutely critical, you know how to create the null hypothesis and the alternate. The null hypothesis has the equality sign in it. The alternate does not. So when you read the question might state the null hypothesis. It might state the alternate hypothesis. For example, I'm going to state that the class average is equal to 72. That is the null hypothesis. And the alternate would be it's not equal to 72. I could say that the class average is not 81. Well, not is the not equal to sign. So the HO would be equal to. So you wind up with the same two-tailed test, but one was stated in HO, one was stated in H1. So you have to be careful. Like that 52 that we did before, did it say 52 or greater? No, it said more than 52, or over was the exact word. And then we also did hypothesis testing on means. and proportions. So hopefully that it makes it clear, and it'll become even more clear. We go through some examples, but I strongly encourage you to set up your Excel spreadsheets that you're going to have ready for the tests to be able to do well on the quizzes. There's no reason why you can't have those done ahead of time. And I won't see them. How you do it is your own business. You could use the website, or you could just use the Excel spreadsheet, which I'll focus in on.